As I've mentioned several times, even though one is tempted to say that this is ex minus 1 is equivalent to x, and e sine x minus 1 is equivalent to sine x, both when x goes to 0, right? This is the basic equivalence, and this is an equivalence that is true because the sine of x goes to 0 when x goes to 0. Even though one is tempted to say that the exponential is 1 plus this, or is equivalent to 1 plus this, and this exponential is equivalent to 1 plus that, we have here a difference, and therefore it's not recommended to do that because you can make mistakes, right? There may be cancellations of small terms, and that gives you wrong results. So in order to do this limit correctly, what we have to do is something different. And this something different is, for instance, this. Let's factor out in the numerator this second exponential here, right? So we're going to rewrite this limit as the limit when x goes to 0. We factor out this exponential, so sine x. And then what we have to do is to subtract here minus sine x, because the product of this and this recovers the exponential of x, right? And then you have 1 here, and down here you have x minus the sine x, okay? Right? Now, the limit of this is 1, because the sine of x goes to 0 and the exponential of 0 is 1. So this limit is just 1. So we can just rewrite this as the limit when x goes to 0 of the exponential of x minus sine x minus 1 divided by x minus the sine x. And the point here is that x minus sine x is something that goes to 0 when x goes to 0. So it's something that goes to 0 itself, right? So this exponential, okay, follows the pattern of this equivalence here, right? When x goes to 0. This is x. If this holds true when x is small, when x goes to 0, then since this goes to 0, plays the same role, so we have just this equivalence, right? So we replace that here, and we end up with this. This is the limit when x goes to 0 of x minus the sine of x divided by x minus the sine of x, and that is, of course, 1.